Good afternoon, everybody. Welcome to the first in a series of workshops that we're going to be running. It's just a couple of minutes past 1 o'clock my time. So probably be a few more people who are going to be joining us in the next 5 minutes or so. Let me just get things set up. If people have questions already about how we're going to run things or any issues that you've already run into, please feel free to start the discussion on that. I'm going to link a few things into the chat, which is hopefully going to be useful for everybody to view. I'll probably have to relink these things a few times. So the first link here is sort of the main website where we're going to be referencing for all of the content. From that website, you'll see a link that says collaborative notes, which is a fancy word for a Google document. So the collaborative notes that I'm linking is a place where you can see all of the links to the different resources that we're going to be using. There's the Zoom link in case you get kicked off or disconnected. An overview to other workshops that are in this same series. It's also a place if people want to make some notes or ask some questions. You can do that in the collaborative document. We can also use the Zoom chat as well. I have a little bit of a gripe with the Zoom chat, which is that it seems to be if you get kicked out of the meeting and rejoin, you lose the history of the Zoom chat, whereas that's not going to happen with the Google Doc. So that might be a better option for people. So I see we're getting more and more people joining. I might start sharing my screen, getting this all set up. Yes, get that done. Okay, so don't need to see that one. I do want to see. Okay. Put the chat over here. See when people do stuff. All right, so there's a lot of different things that I want to talk about today. But this isn't just about me talking. This whole workshop is meant to be a collaborative workshop, or interactive, I should say, very interactive workshop. So I have a lot of content that has been prepared, and just judging by my own previous experience with my own content that I prepare, I've probably got more content than we can really get through today. But that's not super critical. We'll just do as much as we can, as much as we need to, that's going to be useful for everybody. So what I would like to start with is a sort of quick, maybe if people could make a quick note in the collaborative documents, just to say who you are, what you're hoping to get out of this session, like one or two words about what is the interesting thing that has brought you to this particular workshop. I'm particularly interested if there are people who are not from an astronomy background, what it is that has attracted you to this workshop. And whilst you're doing all of your introductions, I think I might start with some of my own introductions. So hello to everybody, welcome. My name is Paul Hancock. I'm a software developer, previous radio astronomy researcher, and now I manage the training for the Astronomy Data and Computing Services project. So this is a project that is aimed at providing training and software support to primarily astronomers all around Australia to effectively fill the gap between what you were taught during your undergrad and PhD and the skills that are actually needed to be doing research. So this particular workshop has been developed as a bit of a collaboration between ADAX and also the Astronomical Society of Australia, the ASA Early and Mid-Career Researcher, or the ECR chapter. So shout out hello to Ilya, who is here. I believe he's still with the ECR chapter. So we've worked together to identify a set of skills that would be useful for people in their research careers, particularly computing skills, and also particularly I like to focus on things that are not specific to a particular domain or subdomain. So that means I'm not going to be teaching you how to use things that are very specific and only used in radio astronomy or optical astronomy or whatever particular analysis that you might have. I like to focus on general skills. And to that end, I've also decided that it's time to advertise and invite more widely than just the astronomy community. So I'm hoping that we get to see some colleagues or some people who are outside of astronomy as well. So that's sort of my spiel. That's kind of my getting started. Hello to everybody. I'm interested if anybody has any, would like to do any short intro. Ilya, do you have anything to say from an ECR chapter perspective?
Paul, if that's to me, I'm not involved in the ECR chapter.
You're not involved anymore. Okay, all right. Okay, no worries. That's my mix-up. All right. Well, maybe we should get started then. So the as I said before, the primary place that we're going to use for our instruction is the website that I've developed here. What I'm going to be doing is working through the content of this website. Some of it is more kind of lecture-y type material, which is me explaining things to you. Those sorts of activities I'll tend to go a little bit faster because the website is here for you to read and to access after the event. And I'm sure that everybody here can read faster than I can speak. And the other thing that I'm going to be doing is live coding. So in this terminal down the bottom here, I will be doing all of the things that we're talking about. And I invite you to do the same. So whether you've got two screens or one screen, set yourself up so that you can see either the video that I'm projecting or the website, and then also have your own terminal open. Now, at the bottom of the front page, there's a note about the setup, which I hope you've all had some time to look at. I've tried to keep the requirements for this workshop as minimal as possible. So the two things that we will require is a bash shell. So depending on your operating system, for pretty much anybody who's not Windows, you don't have to install anything. And then also a Python interpreter. So if you've got those two things, everything's great. You'll be ready to go. If there are any parts of the workshop that I do where you're getting different results to what you see me getting, this might be an operating system difference, but please just shout out, either put your hand up, put something in the chat. If you're brave, unmute yourself and interrupt me to ask a question. I'm always happy to have questions during the workshop. To me, that is sort of the main benefit of a workshop, rather than just you reading slides, is that you're able to interrupt, ask questions, get all of the help and information as it is most relevant. So, all right, let's start with, and I don't think I have missed anything out so far. So we'll make a beginning. So where are we? We're going to start with the first workshop, which is called How to Automate the Boring Bits. So I thought this would be attractive because people don't want to do boring stuff. And if we can automate the boring stuff, then hopefully that's going to make our lives a lot less boring and a lot easier. I think I'm actually going to have to move this chat away so that I can read everything here. Okay. So there's a lot of aspects of research which are quite repetitive. They're the sorts of things that you would do maybe not on a daily basis, but you would do on each project basis. So some of the high level things here are like retrieving data, doing some pre-processing on data. So those two together, we call that sort of like maybe data engineering. Then we do the data analysis, which tends to be sort of the fun bit that people enjoy. That's the having a hypothesis, asking questions, exploring the data. That's where a lot of the research activity really is. Then there's report generation, which is either writing reports for your projects, or in academia, typically this takes the form of making a poster, a presentation, or a paper that's representing whatever it is that you have discovered in your contributions. And then there's another bit here which I've listed, which is just about environment setup. And this is maybe not something that you do already, but it's something that we're going to be touching on in this first workshop. So these first two parts here, this data retrieval and data pre-processing, this is what I want to focus on as kind of the boring bit. This is the bit that a lot of people will probably spend less time than they should on these two parts of the research process. And if we can automate this, and if we can make it so that these boring parts are reproducible, easily reproducible, then that's going to help all of our research. Now, I didn't write in here this data retrieval. This kind of also covers whether you have to go and do some observing or whether you have to do some experimentation, okay? I'm not going to automate that bit for you, although most observatories and other facilities are moving closer and closer to having it as automated as possible for their own benefit of less downtime, etc. So the reasons that automation can help is these 5 things here: efficiency, consistency, reproducibility, scalability, and documentation. The things that we're going to focus on today are consistency, firstly, and secondly, also efficiency. So you've probably been in the unfortunate or fairly common situation where you have had you've done some analysis on some data, you've shared that with either a colleague or a supervisor or a peer, and you've told them the story about what you think is happening, and they've asked a whole bunch of questions, and then you're not quite sure how to answer the questions because you don't 100% remember exactly what you've done to your data. So they might ask, why aren't I seeing these particular features in this plot that you're showing? And you think it's probably because I filtered them out, but I don't at the moment remember exactly how I did my filtering. Let me go back and redo that just to check. And this is the sort of cycle that I want to break here. I want you to have the tools required so that when somebody, either a peer, colleague, or maybe even you just in a few months' time after you've finished teaching and you're coming back to your research, and you can say, I don't remember what I did, but it's all documented here. I can see exactly what the process was. Okay. All right, so there's a few different tools for automation that we're going to work with. We're going to work just with scripting languages today. We're going to use Python and Bash. There's a couple of notes about Nextflow. We're going to use Make a little bit as a workflow management tool. And I'll give the caveat up front that Make is not a great workflow management tool, but for simple workflows that we're going to be developing today, it's good enough. So we're going to use it. Some things that we're not going to touch on are version control and continuous integration. They're sort of more advanced topics that people can ask about, and maybe we'll talk about in the Thursday meetup. So once people have had a chance to digest some of the activities today and maybe had an opportunity to attempt to apply these skills to your own work, you'll have some additional questions. So maybe we can talk about that more on Thursday if people are keen. It's sort of hard to not note that large language models, things like ChatGPT, are going to be extremely helpful for most things that you're doing. A lot of the coding work that I do, I end up using GitHub Copilot just to either give me ideas or write a bunch of boilerplate stuff so that I can just get things done faster. So of course, these are great tools for helping out all of your work and for essentially, I guess it's a form of automation. I'll just make a very, hopefully, a note that nobody really needs to hear, but just be aware that these LLMs, they're not amazing. If you think of an LLM as something that scrapes the internet and just finds what it thinks are the best solutions, you should apply the same amount of skepticism to the results of an LLM as you would for anything that you find on Stack Overflow or any other internet forum that you go on. And just remember that at the end of the day, you are responsible for any of the results that you publish. So even if you did use an LLM to help you out to write a report or to do some data analysis, at the end of the day, you're the expert and you're the one responsible. So having said that, I guess I'll admit to the fact that some of the content today, some of the code that I had written, I got Copilot to just smash a bunch of these things out for me. And then I've gone through, modified it to what actually makes sense. And so, of course, any of the mistakes here were generated by LLM, but they are, of course, my responsibility to take them up. So let's see, I've done a bit of talking. Does anybody have questions so far before we get going? Anything that's not working? So far, so good. Everybody's quiet. Okay. All right. So what we're going to focus on today is a disliked and overlooked time-consuming aspect of research, which is data cleaning. Okay. So I'm going to focus in on a very particular piece of data cleaning, which is we're going to download an existing catalog of data. The catalog has some interesting choices that have been made for the physical format of the tables, as in they're not standard tables, unfortunately. So we're going to have to do a little bit of work to those tables to get them into a more standard format that can be handled with by our various analysis tools. And we're also going to be doing a bit of filtering of those data for a particular task. So the task that we're interested in doing, or the task that I was interested in doing back during my PhD, was preparing catalogs of radio sources for analysis. The particular catalogs that we are looking at are not super important. The actual analysis that I was doing is not super important either, except to say at the end of the day, there is a piece of information that I want that is in each of the 3 different catalogs that we're going to look at. And I needed a way to download the catalogs, select only the relevant pieces of data, and then put this into another piece of software, which is going to do some matching, maybe do some plotting and some other analysis as well. Now, I would like to say that I'm going to show you the code that I developed during my PhD, but of course I wasn't as enlightened as I was today, whatever that was, 15 years ago nearly. when I finished, or when I started rather, my PhD. So I did things really a bunch of bad ways. But lucky for you, you're going to get to learn from my mistakes. So at the high level, the three activities that we're going to do is obtain a catalog of data for a given radio survey. We're going to clean and filter the data, and then we're going to convert the data into a standard format. That's all we're going to be working through today. And I've hopefully designed this in a way that if you don't deal with radio catalogs, or if you are not from an astronomy background, that it won't matter. But please feel free to ping me with any questions that you have about things that you think are unclear. So what we're going to do is we're going to look at how we would do all of this manually, because this is how you do everything for the first time. Okay, the first time you're trying to do something, don't jump into your favorite programming tool. Don't do any of this vibe coding garbage that people are talking about. Do the thing properly and do it yourself by hand. And then once you've learnt the lessons, once you've understood what needs to be done, then you can make a program do this work for you. Okay, so we're going to start off with a workflow for humans. So there is a data set which you can access at this repository. So if I click on that, of course it doesn't work. Wow, stupid thing. Okay. Well, I'll fix that, won't I? Let's go to proper repository. Here's the workshop series. I don't want to edit the 404. There is a data workshop 1, and that's the one that we want. Okay. Okay, so I'll post into the chat the actual link. I have no idea why it's broken. But of course, yesterday it wasn't broken. That's just the way things go. Let's say here, correct link for the catalog is this one. Okay, so there's a particular data set that we want to download. I should actually download that myself as well. So let's see, is it going to download? Yeah, I'm just going to save that in my downloads. Okay. All right, so we can see here, we've got a data set which appears, well, it claims to be a .tsv. So the file format is TSV, which is supposedly a tab separated values. Some people call this Excel, but that's not actually what Excel does. So it's essentially a CSV format where they've used tabs instead of commas. You can see that in this catalog, we have a lot of comments at the top of the file. So everything that starts with a hash is a comment. And this is telling us interesting information about the data set. So for example, the first bit says that we downloaded this from the Vizier Astronomical server. It's got a bunch of information here about the request that was made, including the exact link to how I can get this record again. So if I wanted to copy paste that into my browser, I would get the original table again. There's a bunch of other things here which I'm going to skip over. There's some metadata here that's telling us about each of the columns in the data set. And it's telling us the format of the column. And then it's got a bit of a description here about what that column data represent. And then there's this UCD thing, which is meant to tell us kind of similar information in a fairly standardized way. Much of this we don't particularly need. What we're really looking for is this table of information here. So we've got all of the table headers. Unfortunately, we have a line, a row of just dashes that are as big as the table headers. And as far as I can tell, these are just for decorative purposes only. They don't, this row here of dashes serves no actual useful purpose. And then we've got the actual table data. And if we scroll through, there's just heaps and heaps of data. You'll notice that some of the columns here, like the column Q and flags and this LP, P20, whatever that's supposed to represent, sometimes these columns are empty. There are also, where are we? There's more columns than I can show on my screen. So if I zoom out a lot, maybe I'll get, okay. All right, not super helpful, but if I zoom out enough, you can see that there are some columns. We can't read the details, but some of them have a lot of missing data in. Okay. So there's some of the features, properties of the data table that we're going to look at. So if you open it in Excel or LibreOffice or something like that, you'll get a slightly better view than what I was just doing then. So let's see, the workflow for humans is download the data set. We separate the metadata from the table data. So in this case, the metadata is everything that has a comment, a hash in front of it. So we want to split out the metadata, save that in a location in case we need it for later reference, but then we want to have the table data in its own file so that it can be accessed with all of our analysis tools. We want to remove the second line of the table, the one that has the unit names and also the one that has all of the dashes in it, because they cause confusion for our analysis tools. We want to count the number of rows in the data and record this for later use. We want to correct the data types of the columns. So unfortunately, most of the columns are strings because we've got a bunch of missing data. So the analysis tool we're going to be using is Pandas, is a Python module. And when it sees a column, it looks at all of the entries in that column to figure out what the data types are. And if you have entries that are blank or spaces, it says, oh, that's a string. So therefore, this must be a string column. Some of the columns we're interested in are this one called S8 and S5, and they're supposed to be numeric columns. They're supposed to be numerical data. So we've got to fix that problem. We also have to remove the rows that don't have any data in the S8 or S5 column. For reasons that are not really relevant here, we only want rows that have the RA column with values that are between 12 and 18 hours. I should have written hours there. Just writing notes for myself for all the things that I've done wrong. Count the number of rows that were rejected in case we need this later. Delete the columns from EP onwards. So from this column here, EP onwards, the rest of those columns are not useful for us. So I'm just going to delete them. And then we want to save the filtered data for analysis work later. And we're going to save it as a CSV format. Okay. So they're all of the different activities that we could do by hand. Okay. So I could filter all of the rows. I could change all of these things. I could do this by hand using Excel or LibreOffice or something like that. And at the end of the day, I would have the same output. Now, what's going to happen if I need to redo some of this work? So in the situation that I mentioned before, maybe we have a colleague that says, oh, yes, you filtered between 12 and 18 hours of RA. I'd like to see a similar analysis for, let's say, 18 to 24 hours of RA. How would I go about redoing all of this quickly? Well, unfortunately, at the end of the day, I can't redo it quickly. I would just have to redo the whole thing by hand. And that's quite tedious, and ultimately it's a waste of your time. Okay, so So let's see, a new version of the catalog comes out. How long does it take you to redo this? I have seen some people who have been very close to publication of their paper, and a new version of one of their source catalogs comes out. And they either have to publish the paper as is, and of course, the first thing the reviewers are going to ask is, why didn't you use the most recent version of the catalog? So you either have to strongly justify that, or maybe you just have to go back and reprocess your data. If I wanted to have extra filtering steps, how could I redo this? So there's lots of things about how do I have a way of capturing all of this filtering that I've done, so that I can either redo it easily in the future, or at least have a documented list of these are all the actions that I took. Okay. All right, so questions about this so far? Raise a hand, put something in chat, or just unmute yourself if you would like to ask a question. All good? Okay. All right. So now we're going to translate all of this into a workflow for computers. So this is where we're going to have to start doing some activity. So for each of the steps that we've done, that we identify above, we need to select a tool that is going to be able to do that task. Now, I recommend that you don't try and use one tool for everything. That's usually a bad approach. Choose for each of these activities one tool that's going to do that very well, and then we're just going to link all of those things together at a later stage. Okay, so the three things that we're going to be looking at are downloading the data, separating the lines of a file based on its content, and filtering the rows or columns of a table. So the three tools that I've identified here is that we're going to use either wget or curl for downloading files. So depending on which of those two are available to you. We're going to use the Linux command line tool called grep, which is really good for selecting lines of a file based on their content. And then we're going to use the pandas library for manipulating our table. So let's begin with downloading the data from a remote source. So we can either use, as I said, either use wget or we can use curl to do this. Now I know we've already downloaded the data. I've already clicked the link. I went to the page. I downloaded the data. It's sitting in my downloads file at the folder at the moment. But I've got a workshop 1 folder, which is where I'm going to be doing all of my work for today. Let's just pretend my project is called workshop 1, and this is where I want all the data to be. So what I'm going to do is I'm going to download the file using wget. So I'm going to copy this link here, and this should be the correct link, not like the other one that I had. And from here, if I just type wget and then I paste that in, I should get, stop selecting things, please. Whatever, I'll just press enter. All right. So I get a whole bunch of output, which says time, the URL, resolving, blah, 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 blah. I have this little progress meter that went pretty quickly because the file's not very big. And eventually it tells me that I downloaded this file, it was saved, and it was running at that download speed. Okay, so if I look in my local directory, there we go. I have a file which is about, 5 megabytes, 5.5 megabytes, no, half a megabyte. And it's called at20g.tsv. So that's the first automation. Okay, now I've done it this way because I don't want, even when we go and redo our downloading, I don't want to have to go to the website and remember exactly what buttons to press. I want the exact link. Now, if this doesn't work for you, if you type wget on your computer and it doesn't work, it's probably because you don't have wget installed, and you may instead have another tool called curl. This isn't a Windows versus Linux versus Mac OS thing. This is just a different systems randomly have these things installed. So if the wget didn't work for you, you can try curl instead. The syntax is almost the same. You just have to write minus capital O in here. It'll show you essentially the same information in a different format. But at the end of the day, we want to get this at20g.tsv file downloaded. So that's our first kind of breakpoint. So I'd like to get thumbs up from people to show that this has been completed and everything's okay. And if anything is not okay for you, please use the raise hand button or type in the chat, and we'll see what we can do to address the issue. Okay, a couple of people with thumbs up. Cool. All right. Oh, the thumbs don't stay forever. Okay. Forgot about that. Okay. All right. I'm seeing thumbs up. I'm not seeing yet anybody saying that it's not working. So stop me if I'm going too fast. All right. So that was the first thing that we did, and it worked for us. So we've now got a command. The first command here, wget all of this. This is the first command that we know for our workflow actually works. So what I'm going to recommend is that we make a new file that's just called workflow, not workslow, workflow.txt. So if you type touch, it'll just create an empty file. And then I'm going to edit that file. And I'm using VI so that it's in the terminal so you can all see what's going on. You can use any text editor you want. I'm not weighing in on that war. So in here, I'm going to paste the first command that worked. And I'm also going to put a little comment above this to say, download the at20g file raw format. Okay. So I'm just going to save this. So now I've got a workflow.txt. Now that workflow doesn't do anything yet. That's just me recording the success that I've had. So normally what will happen is you won't get it right the first time. You'll have to remember how wget works. Maybe the link's broken. But once something works, copy it into a workflow file so that you can remember how you got that. Okay. Now we should have this at20g file in our working directory, which looks like this. Here's all the content of the file. And anytime you see these three little dots here in this website, this is me cutting things out of a file and saying I'm not going to show everything because I don't want to show the entire file. Okay, so I've cut out a bunch of data from the file because otherwise it's a bit pointless. So anyway, so you probably won't see those three dots in the file itself. So what we're going to do is we're going to now try and figure out how to get the metadata, which is the rows beginning with the hash. We're going to take that metadata and we're going to put it into a different file. We're going to fix up the header information for the table and the columns so that we've only got the name of the column header rather than trying to describe the data type. And we're going to have the data for the table with tabs separating each. So currently has tabs, we want it to be spaces. So this is where our next tool called grep comes in nice and handy. So we can use grep in the following way. So you say grep minus E, E means like expression, and then we give it a little pattern here. And this pattern says, I want lines that start with the hash character. So this caret is a special character that represents the start of a line. So we're saying, show me all lines where we've got the start of the line and then a hash character. So if I type this in here, grep minus E caret hash, and then the file name. Now it's showing me only the lines of that file that match the pattern. And at least on my terminal, it's got some fancy highlighting, which means that the part of the line that matches the pattern is highlighted in red. So we can see what we've done here is we've selected all of the metadata related to this survey, all the metadata in the file. So what we can do is, if this is selecting the metadata, then I can pipe this information using the little right angle bracket. I can say, don't show me that on the screen. Let's put that into a new file called at20g header.txt. Get that out of the way. All right, so now when I press enter, it should return nothing to me. But I should see that I've now got a new file called at20g header.txt. And if I type, let's use less on at20g header.txt, we can now see, yeah, all of the header information is in here. Just going to press Q to quit out of that. So we've done the first step, which is separating the header, or rather, we haven't really separated it because the original file's not touched yet. We've copied the header data out. So let's find the command that I used. It was this one here. I'm going to copy that into my workflow. I'm going to put a comment, copy header data to, sorry, not header, metadata. That's what I should be calling it. Metadata to separate file. And this was the command that I used. Grep, yep, paste it all into there. All right. So let's save that. And so now our workflow has 2 steps in it. So you can see we're just going to follow through this same process over and over as we go through. All right, questions so far? Nothing's coming up. Okay. All right, let me maybe ask a different question. Is the content that we're going through so far fairly easy for you and you would like me to go a little bit faster? Or is this something that you feel like is actually still worth going at this pace because you're learning things actively? So let's maybe if people can either put in the chat or into the document, if you would like faster or slower. Now, if this was an in-person workshop, I'd have the old red sticky notes and green sticky notes to help people, but of course we don't have that here. I don't think we've installed those emotes onto this Zoom meeting. Not much feedback. Some people are saying faster. Okay, great. Somebody's brave. Let me go a bit faster. It's a good pace for other people. Okay, good, right. All right. So, excellent. Thank you for the feedback. Familiar content, but happy to review in detail. Okay, good. I like that attitude. Even though I know, if I was in a workshop like this where I know a lot of the content, following along with somebody showing you how to do something you already know how to do, there's always opportunities to learn how to do it differently. Okay, Alex has a question. Is there a reason why my grep is taking a long time? Well, it shouldn't take a long time. Did you just type grep -e? Did you just type this and press enter? And then it kind of hangs and yeah, okay. So it's not taking a long time. It's just waiting for you to give it patterns to match. Okay, so if you're in this state, just press Control-C and it will quit out of that. So what's really happening is grep it wants you to give it lines of text. And so if you type in a file name, it will read the text from that file. But if you don't type anything, it'll just do things on the command line. So as I type lines onto the command line, it'll filter those lines. So the first one didn't match the filter, but the second one did. And so then it says to me, oh, there you go, that line matched. I never use it this way. I don't know anyone who does. So we just quit out of that bit. So you have to give it a file name for it to operate on. So that's why it seems to be hanging. Okay, I should update that one. Okay, all right. Good. All right, now what we can do with grep is we can do an inverse match, where if we say here, so grep minus v, which means inverse e for the pattern. So this is looking for patterns that start with a hash, but the inversion means that find rows that don't start with a hash. Okay, so if I press enter on this, it'll now show me everything that is not the header. I've got to spell things with the right capitalization. There we go. So what just blazed past was the entire catalog. You can put a vertical pipe like this and then type less so that all of the output from this command goes into this command. So it's a little bit like the angle bracket that we use, but it's not saving it to a file. It's just directly putting it into this other command. So this allows us to paginate, and I can press the up and down buttons now. So I can see the first bit of the output is a blank line. And then we've got the header for the table. So the column names, all of the units, and then all of these funny dashes here. Okay. And again, I'll just press Q to get out of that. So by doing this minus V, we can actually get the inverse match. And this is quite useful. So before we save this to a file, what I want to do is let's first match all the rows that start with the negative sign. And we can see that we're capturing just that one row that's got all of these things in it. Now we can also match the row that was, oh, let's have a look. This might be a little bit trickier. Minus V, minus E, 20g.tsv. I'm just going to pipe this into head instead so that it shows the first few lines. I want the row that starts with the word DEG because this is the row that has all the units and I want to skip those. So if I want to find the row that starts with that, rep minus E starts with DEG 8020g.tsv. And there we go, I found that one. So the nice thing about grep is I can add, so I'm just pressing up to avoid having to type things again because it's a bit tedious. I can put all of these things together and so starts with degree, starts with that, and also starts with hash. So I can put all of these patterns together and grep will check against each of those patterns individually to figure out whether it's going to show the line or not. And if I put a minus V in front of that, now what I've done is saying, don't show me the lines that start with DEG. Don't show me the lines that start with a dash, and don't show me the lines that start with a hash. Okay. So this should give me the header of my, like the column names for my table, and then all of the data. And so what I'm going to do is I'm going to take all of that and I'm going to put that into a new file. And what am I going to call this? AT20G table. So AT20G, move this out of the way. AT20G underscore table dot TSV. It's still the same format. I'm just removing a bunch of the rows. And if I look at that file, should have used less, but anyway, my cursor, here it is. We can see that it has a blank line, doesn't matter. And then it's got all of the column headers, and then it's got all of our data. So this is now in the format that I want it to be in. This is what pandas will understand. This is what will be helpful to me. So I've got another command that I used, which was this long one here. So I'm going to copy this into my workflow file as well. Workflow, what did I call it? Workflow.txt, there we go. And then in here, I'm going to say remove domain, copy table data to separate file. I'm going to copy that into here. So I've taken this one file and said all of the metadata goes here and all of the table data goes here. So I'll remember now exactly the steps that I've done to get this file. So the workflow that I've got at the moment just has those 3 steps in it. Okay. So now we've gone through download the data and separate the metadata from the regular data, from the table data. Does anybody have any questions? Has anything stopped working for you? Okay. Seems everything is good. All right. So the next thing that we're going to do is to use pandas, which is a Python library. So let's just clear all of that, just so I don't have to look at it. So if you want to know whether you've got pandas installed, firstly, you just type in Python. And I have Python 3, and it tells me it's version 3.12.3. Okay, that's good enough for what I want to do. If I type Python 3 -c and then import pandas, this is just going to run that one line of code which says import pandas. And it's going to tell me that I do not have that module installed. So I'm going to need to install that module. So let me do that now. Pip install. Yes, I need to do this. Okay. Pip install pandas. Blah, blah. Oop, what's it going? Yeah, okay. It doesn't want to install things for me. I was hoping to get to these package managers later on and not have to deal with them at the moment. I think I might have to just install pandas. I have to make a virtual environment. All right, let's skip down a little bit to virtual environments. So I'm going to make a new virtual environment. So the complaint that you can see here is telling me that it's installed. I tried to install a Python packages system-wide, and Ubuntu doesn't want to do that anymore. It thinks that it's a bad idea, and I agree, which is why I'm not going to do it. So what I'm going to do instead is use a Python module called VENV, virtual environment, and I'm going to create a new environment that's called .env. Actually, no, I said env in the thing here. So this is just going to, is it going to ask me questions? No, it's going to sit around for a little while and make a file for me. Okay. So virtual environments are a way for you to separate the different installations of software that you have. So in this case, we're working with Python, and I can have an installation of Python that has packages, has libraries, modules installed that are just for this particular research project. And then I can have another way to another directory, another package somewhere else that has a different set of modules installed. Let's see, is there a way to streamline that last command into a single E command rather than adding them each individually? I'm sure there is. So let's see, where's that grep command that I had? Okay. So these things that are in here, these pattern matches, these are all just regular expressions. So I could probably say that it doesn't start with a dash, a hash, or the letter D. And so the square brackets just means one of the following. So this would probably do what I want it to do. I'm not going to save it to a file. I'm just going to say less. This is probably going to do what I want. Yeah, it did. Okay, that worked. So you can combine them into just one pattern. This is a little bit less clear in my mind as to exactly what you're trying to do. And of course, regular expressions, they're super powerful and super fun up to a point, and then they drive you completely insane because you can do nearly anything with them, but they become incomprehensible. So my personal preference is that I only have very simple regular expressions, very simple patterns to matching, and then I just chain them together using the E command. Yeah. In fact, there's a way that you could do it so that you didn't have a match in here. I could say something like draw a pattern that doesn't match all of this, but again, advanced usage of basic tools, I usually don't bother with that. I prefer to be, let's see, jack of all trades, master of none kind of thing. So for a lot of the bash command line tools, I find it to be a good idea to know the basics of how it works. And then if you want to get really complicated about how you could use grep to filter my table to remove blanks and stuff, it's probably possible, but it's easier to do using a different tool. So we just use a different tool instead. Okay. Cool. All right. So did I make that virtual environment? Yes. So I'm making a virtual environment because I need to so that I don't break my computer. So when I ran this command here, it created this folder for me. And that folder has a bunch of stuff in it that looks scary that I'm not going to touch. That's actually all of the libraries and things that I need to run Python. And if I want to run this environment and bin activate, I have to type this. What did I do? Did I spell it wrong? I did. I spelled it wrong with a V. Okay. All right. So when I then say source this file, my terminal prompt changes to say env here. And so this env means that now I'm not working with my global Python installation. I'm working just with a local version that is local only to this directory. So if I now say pip install pandas, for example, it shouldn't complain anymore. I say shouldn't, but it might. No, it's not complaining. Okay. So it's just downloading a whole bunch of stuff. So it's downloading all of pandas itself and then all of the things that pandas depends on. And in a minute, it will finish and say everything's fine. Okay. Pandas is installed. So if I say Python 3 minus C import pandas, okay, it returns with no errors. So that's worked for me. If you're using Anaconda, you may not have to use a virtual environment because Anaconda already makes them for you. Okay, so what did it actually install? Pandas, NumPy. Okay, good. It installed NumPy for me because I want that. And a bunch of other stuff that I don't use directly, so I can ignore. All right, so short diversion to do the install pandas. We'll come back to that in a little bit. What I'm going to do is something that I very rarely do, and that is use Python directly from the command line with no fanciness added whatsoever. Okay, this is where it gets a little bit spicy. Lots of opportunities for making errors. So the first thing I want to do is import pandas as PD, because we're going to need that library, and import numpy as np, because we're going to need that one as well. And then we're going to load our table. So pandas calls tables data frames. So I'm just going to use df as the variable name. So pd.read csv 20g table.tsv. And then we have to tell it it's actually not really a CSV file, but it uses tabs as the delimiter. Okay. So if I do this, it works. If I type df, it should show me the content of that variable. So it's showing me that this is what my data frame looks like. And I can see I've got all of the columns that I wanted, and I've got these nice column headers. So everything seems to be fine so far. However, if I do df.dtypes, this will show me the data types for each of the different columns. And you can see that the data types are either float 64, which is numeric, or int64, which is an integer. 64 with integers or floating point numbers. Everything else is listed as object. And object in this situation means string data type. So we've got things like, this is the name of the source, that's an object, that's fine. These two things here are not in numeric format, they're sexagesimal formats, that's fine that they're strings. However, this column, this S20, says that it's an object, but I actually want this to be a floating point, and that's frustrating for me. So what we need to do is convert the data types of some of these columns. So S20, S8, S5, and then the corresponding E underscore things, they also need to be converted all into floating point numbers. So these represent, so S20 represents the flux density at 20 gigahertz, 8 gigahertz, 5 gigahertz. This E underscore represents the error on that. The rest of these things here, we don't care about, and so we're not going to worry about what their data types are. So we can do a replacement. So what's happened is the empty data points in here, unfortunately, they're not actually empty. Vizier has stored them as a string of spaces, not just a single space, but a bunch of spaces next to each other. So what's happened is the table looks like this. There's a tab, and then within the column, there are 3 spaces, so /s representing space, and then a tab to say we're going to the next column. And that's annoying. What we really want to do is replace that with a np.nan object, which is essentially a null object. That's what we want to happen. So we're going to do a replacement here. So let's do df.replace, and R is for our regular expression. So now we've got another one of these patterns that we're using. So the pattern here is, let me copy it down here where it's a bit larger. The pattern here is the caret means the start of the line, or the start of the, the start of the line. /s means space, and the star means 0 or more of the preceding thing. So we're saying anything that matches 0 or more spaces, and then dollars represents the end of our line. So this is literally a string that is either empty or it's 1 or more spaces will match this particular pattern. And we're going to replace that with nan values, and we're going to tell pandas that we're using regex as the pattern. So it won't match the exact pattern of characters there, but it will interpret it as a regex. So when we do this, we can now see that our table, instead of having blank things in it, it has now got nan values in it. Okay, So it just says NaN, which means not a number. So that's great. However, it didn't actually do anything to the column. If I just type df again, it hasn't done the replacement on the data set. It has just shown me what the replacement would look like. So what we're going to do is save that output into a new variable called df fixed, say it's been fixed, and then it's df.replace, and then I'm just going to copy from back here, copy all of that into there. So now I've got a variable called df_fix, which has all of the empty values replaced with null values. Let me see, did that? Yeah, that's one, I think so. Now I want to do that for all the columns. Oh, sorry, that's already happened for all the columns. Now, if I type dtype, the problem is what the dtypes with an S. Sorry, that's my mistake. It hasn't actually changed the data types of my columns. Even though it's replaced the strings with numerical values, it still says this is an object based column. So I want to change that. And the way that I can do that is to say df fix and then the column name. So let's look at S20, for example, and then as type float. So this is just converting that column into a float column. So it just shows me the result of that. And then what I want to do is save that back into the original column. So we're going to write a for loop instead. So we'll say if the column name is in this list here, S20, and then error, S20, and S8, and then error, S8, S5, and error, S5. Okay, we're going to do a for loop. I need to indent 2 spaces. So I'm just going to say, take the df fix call name as type float. So what I'm doing is converting the column into float-based column and then replacing the original column there. Okay. So if I type this, it gives me the 3 little dots again. If I press enter one more time, Python realizes that the for loop is finished and it will execute all of that. So now if I type again df.dtypes, I'll be able to see, wait, what? Sorry, df fix, we're looking at the fix one. Here we go. All of these ones have now been converted into float data types. All right, then what we can do is df fix describe. So if I run this, so the describe function for data frames gives you a little table of like a summary of what's happening. Let's minimize that for a sec. So it tells you for each of the numerical attributes, how many of them are not 0. So glon, glat, ra, there's 2,836 of them that are not 0. It tells me here that the error, the ES5, only 961 of them are not 0. So it looks like I've got a lot of blank entries in my data set. Sorry, not 0, I should say not null. That's what it is. These are the non-null values. It also gives me mean, standard deviation, a few other statistical measures that I don't really care about at the moment. But anyway, this describe method is quite useful. So what can we do now? We can ask questions like df fix s8 dot is null, and it will give me a big, gotta type all the letters. It'll give me a column of true versus false, which I can then sum together, and it will give me a number that says 1877. So that's telling me that 1877 rows are actually null for that S8 attribute, whereas for the S20 attribute, only 4 of them are null. Okay, so this is now a much, this is where I could write these numbers to a file somewhere just to keep track of, you know, why, like how much of the data have been filtered, that sort of thing. All right, now let's look at actually doing some filtering. How are we doing? Yeah. I might go a little bit faster on this filtering bit. Please don't hesitate to ask questions if there are things that I go quickly over that you'd like to spend more time on. So what we're going to do is we're going to create a mask, which is df fix S5 is null. And this mask is just going to be a column of true versus false. But I don't actually want to figure out where it is null. I want to figure out where it's not null. So if I do this little squiggle in front of it, that actually does like the binary not operator on that whole column. So true becomes false, false becomes true. So what this is doing is saying this mask is showing me where the data are not null in the S5 column. I could write a different mask. I could say df fix this time underscore raj 2000. And I could say, where is this greater than 12 times 15? So the 15 converting my hours into degrees. And this would give me another list of the row numbers where this is going to be true. Okay. So when we're doing this masking, essentially you just treat each of these operators here as something that returns you a column of true and false, and you can join them together by using and. So and is ampersand, this vertical pipe is the or operator, and the little twiddle is the not operator. Okay, so the way that we can do the masking is that we can just build up a mask of all of these different things, and then we can say df fix equals only the rows where the mask is true. Okay, so this is a kind of nifty a nifty way to do the filtering. So let's do the mask originally just for this one. So it's greater than that, and df fix raj 2000 is less than 18 times 15. So I've got a mask here, which is true and false. Then I can say also add to that mask and not df fix S5 dot is null. And I also want to say where df fix S8, I think it was, is null. So I created a mask, and now I'm extending that to include other things as well. All right. And then at the end, I can just say df fix equals df fix on the mask. So now I should have this df fix data frame should only have rows where the S5 is not null, the S8 is not null, and the RAJ2000 column is between 12 and 18 hours. Okay. All right. And then the other thing we want to do, so df fix shows me now that I've only got 181 rows, which is good. It means that I've filtered out a whole bunch of the things that I didn't want. I've still got 35 columns. So I can filter out the columns by just choosing all of the columns that I want in this list here. So in here, I just write all of the names of the columns that I want to keep. So actually, I'm going to be a little bit lazy. I'm just going to copy paste it from here, from the lesson. So these are the columns that I want to keep. Paste it in there. And now when I do dfix, now it says 181 rows, but I've only got 13 columns now. So I deleted a whole bunch of the columns I didn't want. So I've now got columns that go away. Columns that go to S8, ES8, S5, and ES5. Okay, so we're getting there. I now have a table, a data frame rather, called dfix, which has everything that I want. And so I'm going to save it. I want to save it to a CSV format. So I say to CSV, and then let's give it the file name. So at20g final.csv. And I say index equals false because I don't want this column here, this first column that has no name on it. This is just an index column that Pandas creates for you. Okay. It corresponds to the row number, but after I delete rows, you can see that this index has got some things missing in it. It's not original data. I don't care about it, so I don't want to save it. So if I say index equals false here, it won't save that data. So if I press enter, hopefully this will save. Okay. So I did all of that work in a Python terminal, and I made some mistakes along the way. I had some successes along the way, but everything that I just did in my Python session is now here in my history. And if I want to save this to a file so that I can redo this next time, I think there is a way that I can export my Python history. But usually what I do is I just go back and I look at the lines that actually worked and I copy them into a new script. Okay. So I'm going to exit Python now. So I just press Control D to exit Python. And we'll see that I've got my at20g final.csv. If I look at that, you can see that it's in a CSV format. So we've got one row of header of column headings separated by commas. And then we've got all of my data also separated by columns. So it doesn't look quite as nice, but it's easier to manipulate and read format. So now how do we save all of this? Let's have a look. So what I've done, no, that's not the one. Save our data and create a Python script. So if I go back through my Python history here and copy out all of the things that I did that worked, I can make a new file called clean@20g.py. And so that's what I've done here. I did the masking in a slightly different way. So I said, actually the masking here, I should have done it this way. Did it the wrong way to start with. Yeah, that should be an or, not an and. I had an and before. Anyway, I'll use this version now because I didn't pick it up early enough. So essentially, we've imported the data, read the table, replace all the spaces with nulls, change the column data types, filter out all the rows that are null with those columns, and keep only those within the given array range. Then drop the columns that we don't need, which is the same as keeping only the columns that we do need. And then we save all of this to a file. So that's what I would have done before. I would have just copy and pasted. For now, I'm just going to start a new file. Actually, I'm just going to copy paste it from the website because it's faster. Okay. All right. But that's the process that I'll go through. So this, again, even though we're using Python, I still do it manually the first time to make sure that I've got things right. And then I record what I did in the form of a script. So let's see, if I delete the file, which is the final one, I should be able to run this script and it will reproduce that file. It did. Okay. So I'm going to assume that the content's fine. But my script works and it's produced this file here. And you can see that all of the stuff is hard-coded. The reading file name, the output file name, the RA range, the columns that I want to keep, all of this is hard-coded in the file. For now, that is fine because this is now an exact record of what we have done. This is part of our kind of self-documenting part of our workflow. So it's part of our workflow. So let's update our workflow file. bi workflow.txt. And I'm going to add a new one, which is clean and filter using Python. And that's clean at20g.py. Yep, that's correct. So I recorded all of my Python scripts in all my Python commands into a Python script, and then I chucked that into my workflow.txt file. Alrighty, so now, guess what is cool? If I were to delete all of my at20g files, I could remake them by executing all of the commands that are in the workflow.txt file. Let's test that out. So I'm going to move that file, which is to say I'm going to rename it to be a .sh file so that it's like a bash script. I'm going to make it executable, which on my computer things look like they're green when they're executable. And I can run this either directly or let's workflow.sh. At the top of my file, I can run !# user bin and bash. I put that at the top of my file. So this first line here, why did I do that? It's the other way around. That way around. Okay. Just making a note. !. So this is actually a way of telling bash that this file should be executed as if it contained a bunch of bash commands. And this is also the reason why I put my comments with a hash here. So if I delete everything that has an at20g in the name, you may think, holy cow, we just undid all of the work that we did. But if I type bash workflow.sh, it's going to redo everything. Oh no, I deleted my Python script. Okay, I shouldn't have deleted the Python script. That was bad. Let's copy that again. Clean at20g.py. Copy it all in. Control D. Okay, so let's just remove the things that start with at20g. All right, so I've got my Python script, but I don't have any data. So now if I run my workflow.sh, a whole bunch of stuff whizzes past. So this is just downloading the data file. And if I look here, I've now got my header, my table, and my final CSV file all produced. Also this TSV file here. So all of this was produced just by running the workflow. So I've now got an executable workflow that will reproduce everything that we've just worked on. And if I want to change how any of the any of the options for my filtering, I can edit the clean at20g.py file. If I want to change where, like what the file names are or where I'm getting the data from, I can just change the workflow.sh file. Okay. All right. So what questions do people have at this point in time? Did anybody run into any issues? Surely I've made more than 3 or 4 mistakes so far. Everything's fine. Okay. All right. All good. So we kind of skipped over the not skipped over, what am I trying to say? Skipped ahead to this environment management thing. I did this sort of a bit out of order. It's a bit of, it'll take a little bit of time to go through all of this. But given that people haven't had problems, maybe we don't need to spend lots of time on this. One thing I would like to say, though, is that there's nothing in my workflow that tells me that I need pandas to be installed. If I look in my clean at20g.py file, I'll see, oh, I need pandas and I need numpy to be installed. But that requires me to look into the file. So what we can do is we can make a file. This just needs to be called anything you want, really, but usually we use a name requirements.txt. And in here, we write pandas because we need it, and we need numpy. And so that is a way of telling myself in the future and other people who might want to use my workflow which Python libraries I use. Now, just saying pandas and numpy isn't enough because over time, new versions become available. So I actually want to be more specific and tell people exactly which version of those libraries was used so that we can guarantee that my workflow is reproducible. So I can type pip freeze, and this will show me all of the libraries that are installed. Now, the 2 that I wanted to install was pandas and numpy, but it also installed a few other things here. Now, because I didn't explicitly want these other things installed, I'm not going to care about those. I'm not going to say that they're requirements. They will automatically be installed when pandas and numpy get installed. So what I'm going to do is I'm going to look for numpy and pandas, and I'm going to copy those 2 lines into my requirements file. So instead of having just pandas and numpy like that, I'm going to have numpy equals 2.25. And that means I need version 2.25 of pandas and of numpy and version 2.23 of pandas for my workflow to work. Now, probably more recent versions would work and probably older versions would work to within some limits. Pandas 1.0 probably won't work because they made some major changes between version 1 and 2. However, I know that this version works. So for now, I'm just going to say you have to use this version. And the nice thing is that when you're running a virtual environment, I can have different versions of pandas for every single project that I'm working on, and they won't conflict with each other. Okay. So I'm just going to leave this requirements file in here. So my workflow now consists of that file to run, a Python script to do some of the filtering, and a requirements.txt to tell me which Python libraries I need to install. Everything else here, all of these, the data files can be generated using the workflow, and this environment, I can reproduce this Python environment using the requirements.txt file. Okay. All right, so we'll probably have the following files in our directory. The data files, the Python script, an environment requirements, and a workflow. Okay. Is everybody happy with that summary of Python environments and that we move forward, or do you have any more questions that you would like to ask? This is not your only opportunity for questions, by the way. Everything on the website is going to stay. Obviously, I'll fix a few errors that I made, but this website's going to stay as long as GitHub exists. And on Thursday, we'll have an opportunity to go through, I guess, some of the content that we won't get through today because we're clearly not going to have time. But as you try things during the week, if you have more questions, that is exactly the first thing that we're going to do on the Thursday session. Okay, let's have a look. Maybe, yeah, all right. So the next thing I wanted to talk about is project structure, because at the moment I've just dumped all my files into one directory. And there's nothing really here that tells me which of these files is for which purpose. So I find it very useful, and I'm not the only one, I didn't invent this, is that we use a directory structure to separate all of the different files for the different purposes. So there is a suggested file structure here, and we're going to start to use that. So I need to make a directory which is data raw, data processed, data, I'm going to do another one called final. And then let's also, so we'll make all of those directories. So by the way, the -p command here means that data/raw will be created even if data doesn't exist. It'll create the data directory and then the raw directory inside it. mkdir -p also means don't complain when something goes wrong, which is often handy. All right, so what do we need? Data, we don't have any docs. Source, we do, okay. src, that's where we're going to put our scripts. And we're going to leave it like that. We're going to leave some of the things like the requirements.txt and our workflow, we're going to leave them in the base directory. So now let's move at20g.tsv into data raw. Move the at20g header .txt into data final. at20g table.tsv into data processed. That should be processing, whatever, I'll change it later. And what have we got left? Move at20g final into data final. And move my clean at20g.py into the source directory. Okay, so this is a little bit cleaner now. So I've just got a directory called data, a directory called source, I've got a workflow and a requirements. So if I run my workflow now, it's not going to work because I changed a few things. So I need to make it so that all the files are going to go into the right places now. So I'm just going to update my workflow file. And the way that I'm going to do that is to say that with wget, I want it to go into, the output needs to go into data raw at20g.tsv. And then I need to find this file, data raw, and then I'm going to put it into data processed. And then again here, data raw. And then this is actually, sorry, I said that was going to go into the final table. So final is everything's fine. There's nothing more to do with it. Data processed is intermediate data processing. And then this one here is Python src clean at20g.py. So now I'm making it so that the downloads go to the right directory, and my grep commands now understand where all of the files are supposed to be. The one thing that's missing though is I need to change my clean at20g.py script so that it knows where all of the files should end up. So let me save this one and then open my clean file and then say here, this is going to be in insert, data raw. And then I'm going to save it to data file. Okay. Yeah. All right. So this now, if I'm lucky, so let's go into the data file, data directory. So these are all of the files, and I'm going to delete those. I'm going to be brave. I'm just going to say delete all the data files. And then I'm going to run my workflow again and see if it reproduces everything. File not found, data raw, blah, blah, blah. What happened here? Data raw, TXV. Oh, I know what happened. This is not the raw data. This is in the intermediate data file. All right, let's have a look at clean at20g.py. Shouldn't be there. The intermediate one, I think I called processing. Okay. And I guess I have to go data star at20g star, delete the data, and then bash my workflow. Download, do the thing, still doesn't like me. Well, let's see what's in that. Data processing. Processed. Oh, well, I'm just making lots of silly typos here. No, not the workflow. This one. Processed. That's what it's called. Okay. So again, I'm going to go back and delete all of the data. Then I'm going to bash the workflow. So it's downloading the data again. And it completed without error. Okay. So now I should be able to see data, everything, at20g, like this. And it's got all of the data. Okay, so I now have a workflow that's doing what I want it to do. And I have a directory structure that makes sense. Okay. What else is there to say? What questions do people have about any of this so far? Nothing yet. Oh, hang on, let me bring up the chat. Nothing yet. Okay, all good. So we've got about 20 minutes until the end, the scheduled end of the session. And I wanted to just quickly introduce you to a workflow manager, or actually, it's not designed to be a workflow manager, but we're going to use it like one anyway. And it is a program called Make. So on your command line, if you just type Make, it should tell you something like this. No target specified, no make file found, stop. This just means that Make is installed, but we haven't set it up to do anything yet. If you are on Windows, you may not have Make. If you're using something like Git Bash, I don't actually recall if it comes with Make. I can test it quickly, but anyway, if it doesn't work for you, then that's something that we might have to sort out after this session and getting ready for the Thursday session instead. So let's have a look. So make is a system. It's a piece of code that was designed primarily for compiling code in languages like C or Fortran, where you don't just run the file itself. You have to compile the code to make objects, then you link the objects to make an actual executable program. And there was a lot of kind of boilerplate, boring work that people had to do to make that happen. And so this work, this make tool essentially allowed you to write scripts or write processes to automate all of that. So make allows you to define targets and dependencies. So the target is the thing that you're going to create, and the dependency is the things that you need in order to create the target. And then below that, you have a recipe which tells you how to get from one to the other. So in this example here, it says, if I want to make my clean data.csv, I need my raw data. And the way you get from one to the other is by running this pre-process step on the raw data to make the clean data. Okay. So in general, you have a target, you have a prerequisite, and then some instructions like this. So ultimately what happens is that make works on essentially using files as a way of tracking where you are in the workflow process. And so if you set up all of these rules, what you can say is, I want to make this particular output. And then it will say, well, what inputs do we need? Oh, I don't have this input. How do I make this input? And it goes and looks up the rule for that particular input. And it kind of just cascades from there. So what we're going to do is I want to create a make file from our existing bash script. So let's just have a look here. This is the flow of how we created our files. So we started off with no files at all, and then we ran something to get the at20g.tsv file. Then starting from this file, we can make two other files. We can make the header.txt and we can make the table.tsv. And then from the table.tsv, we can make the final CSV file. Okay, so this is where we're saying we start with nothing and then we create these things. So if I told make I wanted to create this file here, it would say, oh, you need this file, and therefore you need this one. Okay, I need to make this file. I need to run this process here because I started with nothing. Okay, so we're going to create a make file. So the file needs to be called makefile because that's what make is going to be looking for. And we're going to start off with, how do we create this at20g.tsv? So if we type at20g.tsv and we say the requirement for this is nothing, and then this indentation here needs to be a tab character, and then we're going to run our wget command. Okay, now I think yes, I did do it here. Okay, so this is our original bash file. We did update this so that it would run with our new directory structure. So I need to update this thing here. But what we're going to do is we're going to say, in order to create this file, which actually, now that I remember, it lives in the raw data directory, we say wget -o, all of this stuff here. So let's copy all of that. So think of this as the top, this is the recipe for making that file. And we can do a similar thing with other files. So if we want to make the header file, we need the raw file. And then this is our command, this is our recipe for making that. So you can see that actually all of the pieces of the recipe here are exactly the things that we had written in our bash script up the top here. Okay, there's one small difference, and you'll notice that here I've written /hash, and I've written a double $ here. That's just a weird, well, not weird, it's pretty common. It's because make itself interprets the hash character as a comment and the dollars character as some kind of variable name. And so we have to escape them to tell Bash, I want the actual hash character here, not some special meaning. This hash character has no special meaning. So once we've done this bit, so I'm just going to copy this from here. And I'm going to paste it into here. Okay. So if I have a make file that's just this much stuff, then I could say make data final at20g final.csv. And make would say to me, stupid tabs. Oh, that's BI being annoying. Okay. I need to insert a tab character, not a bunch of spaces. That's what happens when you copy paste. Okay. All right. Delete, 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 delete. Press tab. Okay. So Python doesn't care tabs versus spaces, but obviously make does. So, all right. Now I'm getting this red syntax highlighting, which should tell me that it's working properly. Make data final at20g final.csv. Cannot directory non-existent. I think I've made the same mistake processing. I made this mistake there. All right. So I made a mistake because I copied things. So here I didn't use processing. I used processed. I think process ed. All right, I think that's all the instances of processing versus processed. So if I say make all of this, it'll say nothing to do. Everything is up to date. Great. However, I have to tell it exactly what the final file is. So we often have these things which are called phony outputs, which is this thing here which says all. So all in this case is not a real file that will get created, but it's just a way of saying make these files instead. And you'll notice there's no recipe here. So this is something that's very common. If we add this to our make file, then I don't even have to tell it which files to make. I can just type make and it will say, oh, by default, you want all of these ones here. The other thing you can do, which is very nice, is you can make another phony thing, which is called clean. And so clean is usually where you just delete all of the intermediate files. So let me put these two together. So let's say all these things. There's no processed versus processing that I need to mess around with. And then at the end of the file, the end, I'm going to create another one called clean, which just deletes all of the data. So now I can say make clean, and it tells me that it's deleted all the data. And if I say make with nothing specified, it will now go and do all of the different processes. So make is nice in that it tells you exactly the command that's getting run each time. So it says wget, and then I've run grep, then I ran the Python, and then I ran this other grep. And you can see that it did things in a different order than what I had intended. But because the filtering of this script, running this script here didn't require the header, make realize that the order wasn't important. Okay. All right. So make is for simple projects like this, a very powerful tool. You can look through the requirements here. You can more or less trace exactly what it's doing. Make gives you some shortcuts, which is special variable names. And unfortunately, the special variable names are all things like dollars left angle bracket, dollars caret, dollars ampersand, all these sorts of things here that allow you to have shortcuts here. So for example, you'll notice that the file that I want to create here, this file is also listed here in my recipe. And this happens a lot. The input file here is also listed in my recipe, which is why they make these shortcuts for prerequisites and targets and things like that. Now, it may be, you may think, oh, this is nice. It saves me a bunch of typing. And that's true. But the problem is that these things here, these variable names, let's just say they're not very meaningful to look at. And after you've written your make file, you'll come back to it in a couple of weeks and it will be pretty much indecipherable as to what the heck it's doing. So I would advise not using these shortcuts. It makes your make files a little bit more verbose, but at least these are a bit more readable and understandable for you in the future and also any colleagues that you're going to send this make file to. All right, so that's everything that I wanted to cover today. There are a few things that we skipped over quickly. There's a little note here about Nextflow, which is to say Nextflow was actually designed exactly to be a workflow manager. So it's a lot more readable and in many ways easier to manage than Make is. But Nextflow requires that you install a whole nother package manager, a whole nother language, a bunch of other tools as well. So we're not actually going to be working with that. But I do highly recommend Nextflow, and we even have an ADAX workshop all about Nextflow if you're interested. So I think what I'm going to do is I'm going to stop the content now, invite further questions from people before we finish up. Further questions? Okay, well, let me ask a question of you, or a favor rather. If we go back to, click on this and we go home. If I can get people to fill in this survey, that would be super helpful. Apart from the little notes that I've made myself here about mistakes that I've made, this would also, the survey helps me develop these workshops into the future and to make them as good as possible. You can either fill that in today if you're planning to attend the workshop on Thursday. Oh, the link doesn't work. Oh my God. What is wrong? Yeah, okay, I will find it. Oh, all right, let me see if I can find it. I'm just going to have to stop sharing. Does it look through my GitHub to see what's going on? Sorry, not GitHub, Google Drive. Open Sesame. Copy the link. Make it short. Okay. This link should work. Oh, I see what happened. Yeah. All right, that's partly my fault. The template that renders all of these websites from the software carpentries, I misused it. Anyway, yes, so if you can fill in that link, that would be awesome. As I said, Thursday is a time where I don't have any pre-prepared content. So Thursday will be an opportunity for people to have practiced some of the lessons that we've been going through today, and potentially coming across a bunch of problems, potentially coming up with a bunch of questions about, you know, I don't like grep, what could I use instead? I have, maybe you've got a different workflow and you want to identify some tools that are going to be useful on the command line to help you automate things. These are all the sorts of questions that I would love to answer in the Thursday workshop. If you can't make it to the Thursday workshop, please feel free to send me an email with your question, and I will either discuss it on Thursday and you can see the recording, or I'll just reply back to you. Hopefully, I'll have time to do both of those things. Okay. Excellent. Thank you all. Thank you for your feedback. Thank you for keeping me honest and telling me when things are broken or don't make sense. And hopefully I will see some of you on Thursday. Feel free to invite people who were not here today. If you've told them how good it was and they've got questions too, everybody's welcome. And then, of course, we've got more sessions that will happen next week as well. Let's see. Yeah, cool. All right. Thank you all.